And we will be joining our next speaker now, Kurtis Baute, who's going to be presenting why the Earth is smaller than you think. And you there?
Yeah, I am. Hello. In theory, you should be able to see
this
my
presentation.
screen now. Is that working for you?
Yeah.
Excellent. And still there, right? Full
Yeah.
screen?
Yeah.
Excellent. Okay, hi. So yeah, oh, and I should probably shrink this. I'll move it over here. Okay. Oh wait, we'll go back. So hi, I'm Kurtis, as you introduced. Thank you. Excited to be giving this talk. And I know a title as such as Why Earth is Smaller Than You Think might be like a little bit of a bold statement or a bold talk to try to give to a group of astronomers and space-minded people, but bear with me. And especially since, as you said, I make YouTube videos. So I've been spending the last couple of years making YouTube videos full time. So I'm hoping that even with that, I'll be able to convince some of you that this is true. And I think it's kind of lucky or ironic that I happen to be giving this talk on the solstice, because the solstice was the first, it's a talk about the size of the Earth. And the first time we measured the size of the Earth was on the solstice, maybe exactly today, 2,260 years ago, which is pretty cool. And back then, this will be a refresher for some of you. I'm sure a lot of you have heard this tale. But a man named Eratosthenes in Egypt used the sun to essentially just using a shadow, and well, using two shadows, he figured out the size of the Earth. And there's a bit of a diagram here showing how that's possible. He knew that in Syene, on noon, on the solstice, there was objects cast no shadow. So if he measured the shadow of something in Alexandria, he'd be able to do some math and figure out the difference between those two, the difference in angle between those two objects, and therefore knowing the distance between them, which he measured potentially with someone on foot or potentially camelback, he was able to calculate the size of the Earth, which is amazing. And his estimates were somewhere between 1% and 16% off. So we don't know exactly how accurate they were because he used an outdated unit called stadia, and we're not sure about what exact unit he was using. But anyway, really cool experiment that I was really inspired by. And as someone that makes YouTube videos, I thought it would be really cool to redo this experiment and make a video about it. Because as far as I'd ever seen, no one's ever done this for the purposes of educating people. So I went out on my bike in Saskatchewan with 2 sundials, and I tried to replicate this experiment in the modern day. My life is very odd, I should say. So why Saskatchewan? Well, if anyone here has been to Saskatchewan, you'll know it's extraordinarily flat. There's not a lot of mountains or lakes or hills, which means that the roads in it go very, very straight. And there happens to be one road that is longer than, it's one straight set of road that is longer than any other maybe on the planet. And so I set up a sundial in Regina, and I biked along that highway 138 kilometers, and I set up a second sundial. And the goal was to measure both of the shadows at the same time and calculate the size of the Earth in order to teach people about how we know these sorts of things. And so that's what I did. I want to preface this by saying that there's some differences between the experiment that I did to measure the world and the one that Eratosthenes did. First, yes, he had a camel and I had a bike, and cell phones, a new technology. But he also only had to measure one shadow at whenever it was smallest. And my experiment's a little bit different, which is that I had to measure both the shadows, and I had to measure them at the same time and align them perfectly with the road. So even though I had a lot more going for me, I also knew roughly what to expect in terms of what outcome I could expect in an experiment like this, but mine was a little bit more complicated in some ways. So with that caveat said, I did get different measurements on these 2 sundials, which is remarkable to me because it meant that in an afternoon, I had biked far enough around the world to see a difference in how the sun appears. And I thought that was really cool. And while biking, you know, I had done the math kind of in my head and realized that in an afternoon, I biked 0.3% the way around the world, which is not to say that I'm a great biker. It's just to say that I was surprised by how small the world was, because that's a lot. That's a large percentage for a day on a bike. My total measurements and calculations came out to an Earth that has a circumference of 120 kilometers. And that turns out to be slightly off. It's the right order of magnitude. The Earth is 40,000 kilometers in circumference, but my estimate was only 17% off of what the real value is, which I was really thrilled with, considering that I was just doing this with 2 sticks and my bike. I was very happy with that result. And as astronomy-minded people, you'll maybe appreciate that being on the right order of magnitude is something to celebrate. And so I did this to make a video about not just how how we do these sorts of experiments and how we know these sorts of things, but also to talk about how we know that the Earth is a sphere. Because as you might know, a lot of people online, especially on YouTube, think that the Earth is flat. And after 27,000 comments on this video, it did really well because people like to talk about the Earth being flat on YouTube. I kind of realized that this is true. Like a lot of people, and a big study came out with a poll of 8,000 people, showing that somewhere between 2 and 14% of people in America, of adults, aren't sure about the shape of the Earth. They're not sure if it's round or if it's flat, which to me is shocking, and it's really telling that we need better and more science education, because we are way off the mark in this, right? We've known this for over 2,000 years, and most people still don't get it. And we also need to fight against misinformation. If you look on YouTube for flat Earth, there are so many videos, and there's no real method on YouTube for sort of warning people, hey, this isn't what the science says. And that can become a problem, as we've seen in many different sorts of issues. So I want to talk really briefly, just in one slide, about communicating science, because I think it's really important. My suggestions are just keep it simple. I could have done this experiment in a lot of different ways that would have been more accurate, right? I could have used multiple sundials. I could have used larger permanent structures. I didn't have to measure it with my bike. I could have, measured it with a car. It would have been easier. And in doing all these things, I made my experiment a little less accurate, but it was an easier story to tell. And that's the next thing, is always try and tell a story if you can. So our brains are hardwired for story. And if you want to engage with people, tell them a tale and make it physical. That's the reason I biked instead of driving. I just also really like biking, but if you can show people instead of just drawing things out, that'll be really helpful. And when you can, use visuals. And I'm going to give you an example of that. This image here is the picture that I took for the thumbnail of the video. And that image is a real photo that is a silhouette of me and the sun on the sun. So you can see it here, and if you actually zoom into the image, you can see a sunspot right above my bike bar, top bar. And that image I thought was like a cool way of illustrating sort of what this story was about. It's about the shadows from the sun, being able to measure the Earth, and I'm doing it with my bike. So I thought that was fun, and you don't need to use complicated technology to make things. And that's another thing I always try to tell people in terms of keeping it simple. My brother and I took this photo. I was 150 meters away on a bridge, and he took it with a telescope that I bought used for $15, and the tripod was from a camera tripod, and there's some cardboard and a solar filter and my camera, all just kind of taped together. And my point here is just that it doesn't need to be complicated to get the point across. And so that was one project. And I should say before moving on that the reason that I think the Earth is smaller than you think is not because I measured it to be 17% smaller, but it's because a number of projects have kind of shifted my perspective on the world, and that was one of them. And I'm going to talk about the next one, which is related to this jar. And I actually still have it on my desk. This image is from 4 years ago when I sealed this jar with a bunch of plants inside, and I haven't opened it. So in all of these years, it's just been airtight, and the ecosystem inside has changed and evolved, and plants have lived and died, but overall, they've just kept going. And I thought that was really a neat experiment. It's not the first time that's been done, but I kept looking at that jar on my desk and thinking, what if I could show people how we interact with the air that we breathe on a slightly larger scale than this jar? So I came up with this other video idea, which was to build a giant jar, a 3 meter by 3 meter by 3 meter cube, and put a bunch of plants in it and seal myself inside. And I would call it Kurtis in a jar. So that's this project that I was working on to talk about how we interact with the atmosphere. And the goal, this is me inside on my hammock, which was a comfortable sleep, not really. But the goal was that I would exhale carbon dioxide and the plants would soak that in, and using photosynthesis, they'd turn it into oxygen. And in an ideal system, those all level out and those all balance out. And I knew that this was a much smaller ecosystem than would be sustainable in the long term. As you can see, it's small. There's not a ton of plants. There's only a few hundred. But I was hoping that I might be able to stay inside for maybe 24 hours, and I'd be able to make a number of videos while I was in there. And I should say, of course, don't do this at home. Don't try something like this at home. But I did have a lot of safety equipment. I had multiple ways to measure the carbon dioxide levels and the oxygen in my blood. And I had a paramedic on site, which was one of my friends, Mark Van Eyck, who was happy to volunteer his time off. And in terms of other tools that I had in there, I got a lot of questions about this. I had a bucket, which is very important. And if you're wondering how awkward it is to go to the bathroom in what is essentially a greenhouse, keep in mind that I also had, there were reporters and there was a lot of media attention. So it was not an ideal scenario, but this was the experiment. I spent time in there and I made these videos. And I started at midnight. And I tried to get a good night's sleep, but it was really hard to stay calm for a couple reasons. Firstly, I knew that the weather was going to be cloudy the next day. And as you know, plants need sunlight. So I knew right from the start that I was going to be really, my time was going to be really crunched down. And I had to do it on this day. That was the only day that the paramedic was available. And secondly, I'm trying to sleep on this hammock, and I'm very aware that every breath that I take is adding carbon dioxide to the air. And the carbon dioxide is actually what is the most dangerous component. It's not running out of oxygen that I was worried about. It is the buildup of carbon dioxide. That is why people suffocate. That is why this is toxic. And so I was very, very worried about that, but trying to stay calm, because if I'm not staying calm, then my heart rate will accelerate and I'll breathe out more carbon dioxide. So just trying to stay calm with all of that in mind. But by 4 in the morning, when I woke up after a horrible sleep, carbon dioxide levels were already at 3,000 parts per million. Normally, they're only around 400 parts per million, so they'd risen a lot. And again, I was just waiting for the sun to come out. And even when it did, or when the sun rose, it was cloudy. So carbon dioxide levels just kept going up until they reached 1%. And at that point, my carbon dioxide monitors couldn't even detect it, right? They're not built to withstand that high of a level. So at that point, I had to abort. I had to get out and go to safety because I wanted to be as careful as I could with this experiment. And so this experiment was really life-changing for me for a number of reasons. Even though it was a short time, it was only 14 hours I was inside. While I was in there, the air began to feel like a thick soup. It felt different in my body. And I became very aware that we spend our whole lives in this fluid, this invisible fluid called air, and we need it to stay alive. And at the same time, we're treating it really, really poorly. When I stepped out, as in this image, that was the best breath of fresh air I've ever had. And I had a little heart tracker, and my heart rate surged to 130 beats per minute, which is like what it was when I ran a marathon earlier that year. My body was just really trying to pull in all of that fresh oxygen. So I'll never forget that. I also had a number of other takeaways from this project. For one, when you're in an environment that has a high level of carbon dioxide, it affects your ability to think. And there have been a number of studies on this. And researchers found that if carbon dioxide levels, and I could feel this. I mean, I was having trouble really finding the right words, and things just felt foggy. And researchers found after a lot of experiments that if carbon dioxide levels reach 695 parts per million, which is what we expect that they will reach due to climate change by the end of the century, if we don't change course. If they get that high, then human cognition overall for everyone will drop by somewhere between 10 and 16%. Our ability to think will drop by 10 to 16%, which is something that no one talks about when they talk about climate change, but it's something that I honestly, after this experiment, I just can't stop thinking about. So that was one thing. Another big takeaway for me from this project was that we treat our environment in a way that is very unsustainable. And I now can't stop thinking, like when I couldn't cook food on a gas stovetop in my biodome because those gases would have been toxic to me. And it's hard for me not to wonder when I do something like that now, when I drive in a car and it produces greenhouse gases, or when I get on a plane, it's hard for me to wonder, why do I continue to do those things when the biggest difference between my biodome and, well, there's two differences. One is that my biodome was a much smaller volume of air, obviously. But the bigger difference is that I have no escape. I can't just cut my way out to safety in the earth, right? This is all we have. So why am I treating the planet like this? So I've been thinking about that a lot. One question that I got asked a lot after this experiment was it a failure? I was intending to spend up to 24 hours inside. Originally I was thinking it would be 3 days, and I only lasted 14 hours. But my goal in this, as is true for all of the weird science projects that I do, was to get people talking about climate change, because really that's the most important gas I was worried about in this jar, and it's the gas that we're worried about for the planet. And I found that was an overwhelming success. This, while I was in there, it trended on Twitter, which was not helping me stay calm, and it made BBC News. It was an overwhelming media success, which was great. And this project, over all these different ways of thinking of it, convinced me that I needed to focus 100% on climate change. Before this video, I'd done a lot of different topics in different fields of science, but I realized that this is the #1 issue that our humankind is facing, and we need to be doing a lot more than we are. So now I just work on climate change. And I showed you my graph of carbon dioxide levels continuing to rise. And depending on how you look at the curve for CO2 on the planet, it is also extraordinarily steep. And this is a graph for the last 10,000 years. And you can make it out on the right. It is just a sharp line at the edge of CO2 levels. And that's something I think we need to keep at the forefront of our minds. So this all relates. And I'm going to finally answer the sort of title of this talk, which is how big is the Earth? I'm going to, one sec. And aware that I'm giving this to a bunch of astronomers. I know some of you are probably thinking, well, it's bigger than Jupiter, but it's larger than Mars. And you're totally right. And I think that that's a valid way of thinking of it. And I think for most of my life, that's how I thought of it. And I'm sure that a lot of you have other ways of thinking about it as well. But I think that there's a really important way for us to sort of visualize this question, how big is the Earth? So this is a sort of back of the envelope calculation that I'm hoping to bring across to you. It's 510 million square kilometers, which is a lot, but most of that is water. So only 30% is land, which is 150 million square kilometers. And there's a lot of people on it, right? There's 7.8 billion people on that planet. So divided by all of those people per person, we only get about 0.02 square kilometers per person, which is not a lot of space. In fact, it's less than the size of a cricket stadium. I don't play cricket. I apologize, because I'm sure that most people haven't even seen a cricket stadium, but happens to be almost the math works out that it's almost the exact same. So per person, we have about the size of a cricket stadium, a cricket field specifically. Cricket, apparently they use large fields, so that's granted. This is a person. You can just barely make it out. But per person, that's not a lot of space, because we end up spending about 1/3 of the land that we have on the planet to grow the crops and feed the animals that we use to feed ourselves. So about 1/3 of all of the land on the planet is for agriculture. And a further 1/3 is deserts, whether that's like the Sahara or the Arctic. And so the remaining 1/3 of that single stadium, that single field, is us. That's our houses and our cars and all our stuff, all our waste. And it's also, to keep in mind, we share this stadium with all of the rest of the plants and the animals on the planet, right? So this is, I think, a legitimate way to sort of visualize what the size of the Earth is, because it's in proportion with us. And all of that is to say that we treat the Earth like it's bigger than it is, which is why I think that most people sort of have a misconception of its scale in the ways that matter. I want to finish with talking about one last video that I made that hopefully will tie all of this together by summarizing everything that's ever happened so far, ever. And I'm going to tell you the tale of the Domino universe, which is one of the very first big science project that I worked on. I decided that I wanted to make a timeline of the universe's history using a row of dominoes, where one domino would equal 1 million years, and it would start way back at the Big Bang and go all the way, ticking across each domino, one domino at a time, to the modern day. And some of you know, some of you probably know the exact number. The universe is really, really old. It's 13 billion years old, 13.8. So I needed 13,799 dominoes to make this timeline. And as I wanted to make one continuous line, that row of dominoes turned out to be 300 meters long. And so I got to work, and I had to make the dominoes, because you can't buy that many dominoes. And it took me like a full week just to set them up in a warehouse. And I started filming and making the Domino Universe video. And at the start, you know, the Big Bang, and I should put it in quotations, but I explode a balloon and the dominoes start falling, and we have 13,799 dominoes to fall until modern day. And more than half the way through, 6,500 dominoes left, the Milky Way gets its spiral arms, continuing on, and we're talking minutes are going by. All the dominoes took about 9 minutes to fall. It's a long time. The universe is very old. But 4,000 dominoes left, our solar system finally forms, and then eventually life evolves. And by the time we've reached the last 440 dominoes, and you can see of this 300-meter stretch of dominoes, you can finally see the end on this screen. We have the first big mass extinction. CO2 levels drop, which causes a global cooling event, and 86% of all life on the planet was lost. Trilobites survived, and then shortly after that, they die in another mass extinction, which was caused by the rise in oxygen in O2. And again, we have another extinction event, another 100 million years later, caused again by a rise in carbon dioxide levels. There's a bit of a trend here, right? And I believe this one was the deadliest. Yeah, this was the deadliest. This is the Permian-Triassic extinction, which was the deadliest extinction ever. And it wiped out 96% of all species on the planet. And we keep going, right? It happens again, happens a fourth time. And this was caused possibly by an asteroid impact and or by rise in CO2 and global warming. And then, as you may know, about 66 million years ago, there was another asteroid impact, and which caused global cooling, which wiped out the dinosaurs. And again, all of those 5 extinction events, of them, this is the only one we know for sure was caused by an asteroid. And that led to a change in the atmospheric conditions. Because all of them, what they all have in common is a change in our atmospheric composition. And if you go 66 dominoes further, you finally get to modern day. And the most remarkable thing to me in doing all of this was in realizing that it's just the last 3 dominoes in this whole timeline that is all of human history. You know, we evolved to figure out how to use fire and how to make stone tools. And on the last domino, our species evolves. And the last just fraction of the last domino, the last sliver of it, is all of human civilization. Which is remarkable and terrifying because we are also now in the 6th mass extinction, the Anthropocene extinction event. And it's caused by us, which is the first time in all of these dominoes that an extinction event has been caused by humans or by a single species. And I think that in making this timeline, it made me realize that, you know, we are not immune to these events. And we have a big impact on the planet. And we need to be really careful about our time here and how we use it. So I want to leave you on one, with this slide, I want to leave you on a note of what you can do. Because I think that there's one thing that's very, very important for us to all be doing. And unfortunately, most people, 63% of people, aren't doing it, which is talking about climate change. I'm asking you to talk about climate change with your friends and with your family and with your coworkers, really with anyone. And there's a lot of big system changes that we need to make to be able to keep the planet habitable for our species. But we're not going to get there unless people talk about it and it becomes something that everyone is legitimately concerned about. So how to do that? Just a quick guide. Don't start with the facts. If you start with telling people about the statistics of climate change, it's going to maybe turn them a little bit more argumentative or sort of turn off parts of their brain that really need to hear about climate change, more emotional parts of their brain. And along those lines, listen to people when you have these conversations, figure out how they feel about climate change and where their head is at on the topic. That's really important. Be honest with people. You know, you can be free to be open and express yourself and how you feel about it, and be patient. These things take time. Be relatable. Climate change communicators spent a long time talking about polar bears and what was going to happen to the polar bears. And frankly, I've never seen a polar bear, and I don't know many people who have. We need to make these issues relatable to everyone. And something to keep in mind with that is that every issue is a climate issue. If your friend is worried about healthcare, well, climate change is going to really impact the health of a lot of people. It already is. If they're worried about housing, we're going to see potentially 1 billion people lose their homes by the end of the century from climate change, 1 billion climate refugees. So if you're worried about housing, well, you know, climate change should be a big concern of yours. I could go on, but just try to be relatable to people and be persistent. These things take time. I think a lot of people are in denial about climate change, and it's going to take time to change that. Yeah, just be compassionate and take your time. And I don't think I could give a talk about the size of the Earth without closing with a photo from the Voyager 1 spacecraft, the pale blue dot. And if you can't make it out, that little dot is Earth, taken from a very, very long way away. And I think that we need to just remember that that's us. We're all in this together, and we need to do what we can. And thank you so much for listening. I hope that I haven't ruined your day, and I hope that this is helpful to some people.
Thank you, Kurtis. That was fascinating.
Yeah, a little different than I think a lot of the other talks were for this week.
Yeah, I'm surprised that you couldn't buy that many Dominoes.
You can, so you can, but it would have cost thousands of dollars, and most of them are only plastic.
Right, yeah.
And I have a thing where I'm trying not to.
Right, of course, yeah.
Waste plastic, right? So,
well, there's a great comment here from somebody. It doesn't say who it is, but it kind of sums it up. Great thematic conclusion to a wonderful, virtual, and green GA. So. Well, there you go. Thank you. That really sums it up. You know what? Because I say Erastotennis because I never say the guy's name to anybody. I just read it in a book, and that's the way I pronounce it. But I guess it is Erast. So I can't even say that.
I thought it was Eratosthenes.
Yeah,
I could be wrong.
Yeah, but
I could be totally wrong in that.
Yeah, just because I always read it, I never say it. I always said, but you know, I've always read about his experiments and stuff, and especially this one with it's amazing that you reproduced that. That was pretty cool, yeah. But to the flat earthers, even the ancient Greeks knew that the world was round because they could see first the bottom of the ship when it was sailing away, the bottom of the ship would disappear, then the middle of the ship, then the mast would disappear. So even the Greeks were smart enough to know that the world was round. And they even knew that only a spherical shaped object would cast a round shadow on the moon when there's a lunar eclipse. So in a lot of ways, ancient Greeks were a lot smarter, I think, than a lot of people are today. So.
Yeah, I mean, it's partly maybe that, but it's also that there's just a lot of misinformation out there, right?
Yeah,
and people want to believe in the unbelievable, right? They don't want to believe that NASA landed on the moon.
Absolutely, yeah. People would rather buy an Enquirer magazine and get some fantastic story rather than the real. But to me, always the scientific fact and the way the universe really works is the most miraculous thing, you know? So I don't understand why.
I agree with you on so many levels there. And I think that's what we need to remember when we're communicating science to people, right?
Exactly.
It's like we need to, and I know, I mean, you did this in your talk about saying how, you know, this is an adventure and that we can star hop and it's exciting. And I think that it's important to share it that way.
Exactly, yeah. Well, that's great, all those experiments that you do. And I know that the NASA did a few of those biosphere experiments too, like locking them in. That never lasted very long either, did it?
Yeah.
I mean, they were able to stay in for a few weeks, but it also, you know, even with all their money and expense and stuff, it wasn't able to. Anyway, that was great. I really enjoyed that. My one question was that, you know, Eratosthenes. Okay, so the first hole that he put in, that he knew that it would cast no shadow, and then I guess he had somebody else do it 200 kilometers away. I think it was in Cairo or something, and then they shared the information later. But was your first stick casting no shadow, or did you just take the difference between its shadow and the next shadow?
Yeah, I had to do, they both had a shadow. So one was
I see,
70
they both had a
centimeters long
shadow.
and one was 66.
Okay, so why didn't you just have somebody at the second stick communicating with a cell phone or something and measuring at the same time?
And I did, and that was lucky. But I also the error. And I didn't say this in the talk, but my error was not from timing, but it was from my angles, because I didn't, you know, I was using like a small compass to try and line everything up, but it was imprecise. So
right. Well, I work for an airline. I work for Air Canada, so I'm usually up at 35,000 feet, so I do see how small the Earth is. You know, you can see 400 miles around at that, and that's quite a large fraction of the Earth. So I realize how small and vulnerable the Earth is, and I see the looms of pollution just hanging over some of these major cities, and it's terrifying, actually. You know, and that people aren't getting that is so terrifying. You know.
Yeah.
But,
and I hope I kind of clarified at the start. You know, I know a lot of astronomers. They got this figured out, and I don't mean to single you guys out at all. But I just think it's a fun way to think about it, or an important way to think about it.
Curtis,
I saw a comment asking where my YouTube videos are, and they're just on my YouTube channel, which is my name, Kurtis Baute. If you search that, or search "Guy seals himself in a jar," and you'll find
and then they'll all come up.
Yeah.
All right, great. Well, if I run into you on the street, I'm going to drag you in for a coffee and have a long conversation with you, because you seem like a pretty interesting guy.
Thank you. It was a pleasure.
All right. Yes, it was a pleasure. Thank you so much for coming and speaking with us. And maybe we'll see you again on another webinar.
That'd be great.
Okay. Thank you so much. Bye now.
Thanks, everyone.
Yeah.
Thanks, everyone. All the presenters. Thanks for sharing your content today. And I don't think there are any other questions in the Q&A or the text chat. So
except one person was wondering where we shared all that information that we were talking about in our presentation, and it's in the comment, and we've made it public so you can access it.
Yeah. You might have to request access, because all of those files that I had links to are on my Google Drive, and I'm not 100% sure whether you need a Google account to access documents on my Google Drive. If you do need one, then just create like a dummy one or whatever, so you can get access to it. But you might not need access to get those. I just might need to approve it. So I'll watch out for those emails.
Also, we're writing a book about all this star hopping and making it very simple, because we find that so many of the books and information out there are so complicated, so convoluted. There's a lot of holes and missing spots. We just want to start it from square one and go through it logically. So look out for that book, maybe within the next year. And thank you again to all our presenters. Anything else you wanted to say?
No.
Okay. All right. Well, thank you for joining us today at the RASC Vancouver Virtual GA Lite series of webinars. And thank you for attending. Bye now.
Bye.